Welcome to Brain Vision.
So in this case, we have an ideal Rankine cider with water, Rankine cycle, ideal reheat Rankine cycle. I can't talk this evening. Maintains the boiler at 5,000 or 5 megapascals. The reheat section at let's see here. The reheat section here down at not that, we want this down here at 1.2 megapascals. The condenser down at 20. Quality at the exit of the turbine is 96%. At both of these are 96%. So at 4 and at 4 and at 6 are both 90%, 96%. So then we have isentropic turbine and pump. Let's see here. Why did I guess we don't really need T1. I'm not sure why I wrote that in there. So we have then that we're going to get H1 because it's saturated vapor or saturated liquid at 20 kilopascals. And so that's 551.4 kilojoules per kilogram Kelvin. You can get the specific weight or specific mass, specific volume. The specific mass, well, that would technically always be 1, though, wouldn't it? Anyway, from this and the change in pressure going from 20 kilopascals to 5 megapascals, we need to put in about 5.1 kilojoules per kilogram, which then raises the enthalpy up at 2 to 256.5 kilojoules per kilogram. Now, let's see here. At 4, we know the pressure and the quality factor, so we can get the enthalpy and the entropy. You know the entropy at 3 is the same as the entropy at 4. So that gives us the temperature at 3, which is 327.2 degrees Celsius, and it gives us the enthalpy at 3. Now at 6, we also know the pressure and the quality factor, so we can get the enthalpy and the entropy, and we know the entropy at that should be 5. At 5 is the same as the entropy at 6, and so we can get the enthalpy and the temperature at 5. So basically, I guess I kind of drew this a little bit here. So let's see. That should be at a higher temperature. So we go up here to 5, and we're up somewhere around here. So then we got to come up here. All right. So we're at 481 here, and this is 0.5. So we're at 481 here, and down here we're at 327. So then, let's see here. We have the heat transfer in is just this minus this plus this minus this. And that is 3,482 kilojoules per kilogram. The heat transfer out is simply this minus this, the enthalpy here minus the enthalpy here. And that is 2,263 kilojoules per kilogram Kelvin. And from those two things, we can get the thermal efficiency, and that winds up being 35%.